Day 2 of 6.2 and 6.3 is going to continue looking at normal distributions. So these problems today are almost the reverse of the problems we did previously. In the previous problems, we were given a z-score. We went to the table and we looked up that z-score to find a corresponding probability or area. In problems today, it's giving us the opposite. It's giving us the area or a probability, and we're going to use that to find a z-score. For example, find the z-score cutoff where 90% of the area is to the left of the cutoff and the other 10% is to the right. Here's our normal curve. The mean is right in the middle, and in a normal distribution, mean, median, and mode are all the same value. So the mean is also the 50% mark. We want to find the cutoff for the 90th percentile. So right here, 90% of the values in this curve are to the left of this line. So yesterday, we were taking our z-score and we were looking up a probability. So we would start by looking at these margins. Okay, our answer would come from the center of the table. Today, we're doing the opposite. So it's giving us this value. It's saying 90% is to the left of this cutoff right here, which means we're going to start off by looking inside the middle of this table for 90%. Now, the issue is that in a lot of cases, we won't be able to find this number exactly, so we want to find the closest thing to it. So here we have 86%, 87%, 88%, 89%, we're almost there. We want to go to the closest thing we can to 90, and the closest thing is this one right here, 0.8997, 89.97%. That's the closest value in this table to 90%. So the z-score for this value in the table right here has 90% to the left of it, approximately, and the other 10% to the right of it. And the z-score for that value is 1.28, and that's the answer to this problem. Find the z-score separating the bottom 5% from the top 95%. Bottom 5%, that's below the mean. Since the mean is the median, that's the 50th percentile, which means we're looking for something down here. This will be on the negative side of the curve, and we know we're looking for 5% in the table. So load this up. All right, so I see some 4% here. The table is actually going this way. 4%, we're getting really close. Here we have 4.95%. Is that the closest? Over here we have 5.05%. In this case, there's actually two that are equally close. They're both 0.05 away from 5%. When we have two that are both the same distance from the number we're looking at, we're going to average those two numbers. Okay, and when I say average those two numbers, I'm really talking about the z-score. So the z-score for both of these, negative 1.64 and negative 1.65. Okay, so the average of both of these is going to be right in the middle of these two numbers, negative 1.645. Let's do two more like this. Find the z-score separating the bottom 1% and the top 1%. So here we want two z-scores. So we want a z-score for the bottom 1% and the top 1%, this value up here. So let's start off by finding the top 1%. Right, so top 1% means we have 99% to the left of this and 1% to the right. All right, when we look at this table, we can see right down here, we have 99.01% at 2.33. Okay, so that's our z-score for this cutoff. On the negative side, we're looking for 0.01. Closest thing to it, well, here we have 0.0102. Here we have 0.099. We want the closest one. That's this one right here. Okay, negative 2.3. I can't see what it goes out to, but that's 0, 1, 2, 3. All right, so this one would be negative 2.33. This makes sense. It's a symmetric curve. So 0 is in the middle. We're going the same distance this way and this way. So we'll have z-scores that mirror each other, positive and negative 2.33. One last one like this. Find the z-score separating the bottom 7% and the top 7% from the rest of the distribution. So again, we have two z-scores. And again, like the last one, since this is a symmetric curve, these are going to be the same two z-scores, one positive, one negative. So on one side, we have the bottom 7%. So 7% on this side. And on the right side, we have the top 7%. So 7% over here, which means we would be looking for 93% to the left of that. Load up our table. If we find one of these, we automatically find the other one. So let's look for a 7 in the middle of our table here. All right, so I see a bunch of 7s on this bottom row. 0.0708 is 1, 0.0694. Again, we want the closest one, which is 0.0694. So negative 1.48. Okay, there's a positive and a negative one, because if we looked at the positive side, positive 1.48 is going to give us that 0.93, or the closest thing to 0.93. So now let's apply it to some word problems. When designing an environment, one common criterion is to use a design that accommodates 99% of the population. How high should doorways be if 99% of men will fit through without bending or bumping their heads? That is, find the 99th percentile of heights of men. Heights of men are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. I'm going to give myself a little bit more room here and condense the information. So we have our normal curve centered at 69 inches, standard deviation of 2.8 inches. 69 inches is right in the middle. We want to find the 99th percentile, which means 99% to the left of it, 1% to the right of it. So we load up our table. We're looking in the middle of the table. Because we don't have a z-score, we have an area, and we can see down here at the bottom, 0.9901 has a z-score of 2.33. All right, so the z-score for this is 2.33. Now, if we go to our z-score equation, z equals x minus the mean over the standard deviation, and we plug in everything we know. Well, we know a z-score, we know the mean, and we know the standard deviation. Okay, we're looking for this. So we keep that in x. And now we're just going to solve it algebraically. So we start off by doing 2.8 times 2.33, move that to the other side. Okay, now we're going to add the 69 inches to the other side, and we get our answer 75.524 inches. Where 75.5 inches is tall enough where 99% of the population would be able to fit through without bumping their heads. Companies who design furniture for elementary school classrooms produce a variety of sizes for kids of different ages. Suppose the heights of kindergarten children can be described by a normal model with a mean of 38.2 and a standard deviation of 1.8 inches. What fraction of kindergarten kids should the company expect to be less than 3 feet tall? All right, again, condensed up a bit. So we have our normal curve centered at 38.2 with a standard deviation of 1.8. And we want to find, first off, the probability that a child is less than 3 feet. 3 feet is 36 inches, and we want to go to the left of this. So this is a problem like we did previously. We can find a z-score for this and then look that z-score up in the table. So z-score first, 36 minus that mean, divide by the standard deviation, we get negative 1.22. In the table, we're looking at the margins. Okay, so negative 1.22 puts us down here, 0.1112. So 11.12% of kindergarten children will be less than 3 feet tall. In what height range should the company expect to find the middle 80% of kindergartners? So middle 80% means we have 80% cut out of the center and the other 20% left over in the tails. And that 20% is split evenly, 10% on this side, and then the upper 10% on the high side. Okay, that also means that to the left of this cutoff would be 90%. All right, so we would go to our table, we would look up either one of these values, because if we find one, we found the other one. It's a symmetric curve. You're looking for the closest thing that we can find to 10%. Here we would get negative 1. If you looked on the other side, look for 90%, we find positive 1.28 is the closest z-score to that area. All right, so we jump to our z-score equation. Okay, and we're going to have two different equations here. We have one for the lower value, I'm going to label that XL, with our lower z-score, mean and standard deviation plugged in. And then we do the same thing for the higher value, okay? And we just plug in the higher z-score. And we solve each of these out. I have it solved out for the higher z-score here, so times 1.8 on both sides, cancels over here. We get 2.304 on the left. Add 38.2, we get a high z-score of 40.504. Okay, do the same thing to the lower side and we get a range. So 80% of kindergartners will have heights between 35.9 and 40.5 inches tall. Lastly, how tall are the tallest 5% of kindergartners? Tallest 5% means we have 5% on the right side here. And if there's 5% on this side, that means that we have 95% on the left. And it's always the area to the left that we look up in the table. So we go to our Z table, we're on the positive side to of the table because, okay, and when we look it up, we're looking for the closest thing to this. We'll find that there's two things that are closest to that, 1.64 and 1.65. We average those to get our Z-score. Plug that into the equation with our mean and our standard deviation, and then solve it out. Multiply by 1.8, add the 38.2, we get an answer of 41.2 inches or taller for the top 5% of kindergartners.